Hello everyone, let me introduce myself. My name is Olcay Tamer Dawadort. I study at Chumbuk National University. Today I'm honored to introduce my study here. The title of my presentation is The Soiling Classification of Solar Panel Using Deep Learning. Did you know that in written, the third energy master plan of the Ministry of Trade, Industry and Energy, the government of Korea plans to increase the use of renewable energy to 35 to 40% by 2040. Regarding this, the level of technology development contributes to the research field in solar energy system. I have divided my talk into introduction, methodology, dataset, result, and conclusion. So let's now look at the introduction here. A solar system requires regular maintenance such as cleaning, replacement. Therefore, what we should clean and why we should do it. Firstly, I hereby mark out what's the soiling. The soiling term is used to describe the accumulation of the snow, dirt, dust, leaves, pollen, and bird dropping on the solar panels. Those can easily cause more than 1% power loss per day. By recognizing the soiling type, the maintenance process can be predefined. For instance, bird dropping on the solar panels are more detrimental than film of dust. Next, the convolution neural network method is used to classify soiling types using the panel images. Moreover, the proper solution helps to determine soiling on panels automatically and to guarantee notifications. I'd like to emphasize by next section its methodology. As you can see here, on the left side, mixed image of photovoltaic panels representing different soiling and clean, and then feed into implemented model as an input. Then label fixtures emerge as an output on the right side. This picture illustrates the proposed CNN architecture consists of 9-layer sequential model, including 3 of convolution layer, 3 of fooling layer, flattened layer, and 2 of dense layers. In more detail, each convolution layer detects with activation function its reactivated linear units. In the pooling layer, max pooling is used. Also in dense layer, also have activation functions. One is the rectifier function and another one is softmax. Before the training process, images were resized by 150-150. By focusing on hyperparameters, kernel size is 33 and batch size is 64. Epochs was 50 and learning rate was 0.001, and also early stopping is used to prevent overfitting, including patient parameters file. Here is the next session is about dataset. The solar panel soiling image dataset created by Deep Solar Eye is used for proposed model. It comprises of 45,064 9 images of the solar panels. There are several types of the soiling that are described here using sand, talcum, and dust. An additional dataset is created manually, which is the synthetic dataset. Images of dataset were captured at every 5 seconds and RGB camera for about a month. Based on the natural conditions, we split into 6 categories, including clean, cracked, bird dropping, dirt, dust, snow, so on. The ratio of data for experiment is approximately 70% of training, 20% of validation, and 10% of testing. It's clearly seen in the table and how many images are fed into each classification and each stage. Now that brings me to the end of my presentation. It's a result of our experiment. In the testing step, 4,349 images were tested and it contains all the classification. Training process stopped after the 19 epochs, despite it was being 50. Then this is a very high accuracy, which means that it shows 98%, in which 4,262 images are classified correctly. By showing the confusion matrix, for example, in bird dropping case, all 1,066 images were tested, whereas picked up 1,060 images correctly and 3 images were recognized into clean category. Also, 3 images were fed into dirty classification. In conclusion, in terms of prediction results in the classification report and confusion matrix, we have the following observations. Firstly, images of dataset have a very similar characteristic, such as the image color, the position of the photo taken, and soiling appearance. They leading to high accuracy in the proposed model. Secondly, the soiling area of the image for the dirty category is slight, in which few of the features are somehow similar to the clean type. The outcome leads to predicting their belonging to the clean category. Thirdly, the image falls into the appropriate class depending on which has a large area when different type of soiling on the panel simultaneously. I'd like to finish summing up, and an initial CNN method is used to recognize and classify images, determine soiling type on the PV panels. Next, CNN is a powerful method and simpler for the image classification based on the excellent result. Finally, it can be extended the research to solve power loss prediction using object detection and semantic segmentation. Thank you for your attention and for listening attentively. Please feel free to contact me if you need any further information by the following email.